In this video, we're going to work on the ALEKS problem called predicting the reactants or products of acetal hydrolysis. There are a few different versions of this problem, and this one right here is absolutely the hardest version of this problem. It is giving us a starting acetal and is asking us to come up with three different structures, X, which shows up twice, and Y and Z. We're going to draw all three of those molecules in this box down here. I am going to show you some different versions of this problem, but like I said, this one is absolutely the hardest one. To start off, I'm going to redraw the provided molecule. I'm just going to redraw that initial acetal down here. And basically what we're going to be doing in this problem is dissecting this acetal, dissecting it into three additional molecules. I'll just give you a little bit of like hints in terms of where we're going. This reaction is always going to be starting us off with an acetal. And this, in this spot right here, this is always going to be a hemiacetal. Sometimes you're going to be provided with the structure of this hemiacetal. I am not being provided with it in this problem. Over here, this is either going to be a ketone or an aldehyde. And then this X is always going to be an alcohol. And in the different variations of this problem, all of the versions of this problem have this same general structure. You're just being asked, in the different versions of the problems, you're being asked to figure out different things. Like this one, I'm being asked to come up with the hemiacetal, the alcohol, and the ketone or the aldehyde. Another problem, you might be asked to come up with the acetal. Another one might provide you with these things and just ask you to come up with the alcohol. They're just kind of all over the place in terms of what it wants. So I'm going to start by writing up the acetal. And the next thing that I'm being asked to figure out is the structure of the hemiacetal. The hemiacetal has almost the exact same structure of the acetal, except for one of the acetal groups. So these are our little acetal groups out here. One of them is going to be a hemi or an OH instead of an alcohol. So like that. So what I'm going to do is just take one of these guys, and I'm going to convert it to an OH group. And I could have done it with this one. I could have made this my OH group and kept that my OCH3. Wouldn't make a difference. This is molecule Y, and this is one of the things that I need to draw in this box, this molecule right here. Also, we're going to keep going with this. The last thing that we're going to draw out here is the structure of the ketone or aldehyde that we get when the reaction is all the way done. So to come up with that structure, we're going to keep this carbon skeleton. The hemiacetal group, I'm going to highlight that right there, this group right here. In the final version of this molecule, this whole entire thing snaps shut to make a carbon-oxygen double bond like that. Oops, like this. So this is my molecule Z. That's what it wants. So this just kind of shows you the three different versions. Notice that I'm not doing anything at all with this carbon skeleton. Like there is nothing happening out here. These carbons are not changing at all in any way in any of this. So depending on what you've been asked to figure out, depending on what you're starting with and what you've been asked to figure out, follow this exact same pattern every single time. And that should help you come up with the molecules, whatever molecules you're missing, this one or this one or this one. Now I also need to come up with the alcohol in this. So it's telling me, yeah, there's also an alcohol that's being produced at each one of these steps. The alcohol that's being produced is the stuff that is coming off as this acetal is being broken down. So this this is a CH3 out here. This OCH3, we lose it. I'm going to write it in condensed structure. We lose that portion as an alcohol. And then here, we're going to lose it again. It's a little harder to visualize there, but we're going to lose that OCH3 again as an alcohol. So this, for this last piece, we're going to take this OCH3 and we're just going to be ourselves. We're going to be adding a hydrogen atom to the OCH3. We're just sticking a hydrogen atom on the end to make an alcohol. Whatever this alcohol is, and this step kind of makes it relatively easy to visualize the alcohol. This is the piece that we're losing. We're going to make it into an alcohol. It's not so easy to visualize the alcohol in the step between Y and Z, but whatever this alcohol is, it's identical to the other alcohol as well. There's only one version of the alcohol in this molecule. This reaction, I mean, this is molecule X. So for my answer in this box, a lot of stuff in here I would need to leave out. I'll put all this back in a second. This would be the answer to this particular ALEKS problem. These are the 3 structures that it's looking for. And this is the overall schematic of, whatever version of the problem you get. This is the pattern that's going to help you solve the problem.